All right, so hello. This video is going to teach you just the basics of how to use ECrypt. So ECrypt is a software that will automatically encrypt or decrypt a message for you as long as you give it the correct key. So first, how do you get it? Canvas homepage, under online resources, eCrypt.jar, right? This is a Java file, so it should work on any operating system that you have to use it on. Doesn't matter if you need Mac or Windows. Just download this file. Then you go into the software and you simply double click on it. If anybody is having trouble actually running this software, then send me an email as soon as possible and we'll try and get it all figured out. Once you get the software running, you should have something that looks like this. All right, very simple. So first you have the alphabet. You need to make sure that this alphabet is the alphabet that we are using, all lowercase letters. It should automatically be that way, but if not, you can change it here manually or go into alphabet and do capital letters and punctuations and all kinds of other stuff. But it should automatically be set up to just be the 26 lowercase letters. Next, what you need to do is pick your encryption algorithm. We're going to talk about a lot of these, but right now you're going to pick affine. The shift cipher is actually a particular type of affine cipher, which we'll talk about pretty soon. But the specifics are that it's an affine cipher where the multiplicative key is 1, and the additive key, that's the shift key. So really, when you're doing just shift cipher, you only want to change the additive key. All right, and so now it's just a matter of encrypting. So I can write the message, "Hi, my name is Jeb." All right, remember, no spaces are allowed. We'll do an additive key of, I don't know, 19. And you click the encrypt button, and wow. All right, it works. All right, and so then you can click the so I'll get rid of this up here. You can click the decrypt button, and it decrypts it perfectly. Note that if I were to change the key to, say, 3, all right, and this key can be anything. It could be -7. And I hit decrypt. Wow, did I choose the exact wrong one? Let's try that again. There we go. So -7 and 19 are the same thing, mod 26. That was completely random, but kind of cool. All right, so when I use the wrong key, all right, say -6 or 3 or whatever, and I try and decrypt it, it doesn't make any sense. It goes from gobbledygook down here to gobbledygook up here. All right, but it very clearly says what is supposed to be the plain text and what is supposed to be the ciphertext. And you can use this to encrypt some messages and decrypt some messages using a bunch of different ciphers. We're going to talk about the affine cipher. When the ciphers start getting more complicated, it's the kind of thing where you're not going to want to have to encrypt and decrypt by hand anymore. All right, so one more thing, talking about the analysis. Let's say that we have a bit of ciphertext and we want to try and break it, okay? So first, let's just use the shift key of 3. I decrypt it, and okay, that's obviously not right because that's not plain text at all. All right, so we're going to use the statistical analysis that we talked about in the security video. So you click on analysis, and we're going to look at the monograph frequency. A monograph is simply one letter in your alphabet. And so we're going to look at how frequently each of the letters are showing up in the ciphertext. There's a bunch of different things here. Don't worry about decimate right now. All that does is it turns things into different columns. So we're not going to worry about decimate. Just keep that at 1. How many do you want to show? The top 10, top 20, all of them, whatever. All right, that one's pretty self-explanatory. And it tells you which letter shows up in your ciphertext the most. So Q seems to be showing up the most in our ciphertext. And W seems to be showing up the least. So we could take a guess real quick and say, okay, so if Q is showing up the most, maybe Q is equal to E. All right, so Q decrypts to E, and E encrypts into Q. All right, and so we look at a table and we figure out that that would give us a shift key of 12. All right, so let's take a guess. Shift key of 12, we decrypt it. Hey, and now we get something that makes sense. The ultimate goal of calculus for many life science students primarily involves blah, 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 blah. And just to think about the security again, we could have gone the other way with this. We could have looked at L and W. Okay, those are probably Q and Z because those show up the least. And so we could have looked at those and said, okay, well, let's assume the W is Z and done some work there. And that would have been wrong, all right? Because that would not have worked. But L being Z, that one does work. That gives us a shift key of 12. All right, so you can see it's this bit of guess and checking, and this software helps the guess and checking go considerably faster. All right, so download this software and test it. Make sure that you can get it to work. At least you can encrypt and decrypt some messages real quick. And then we'll be using this as we work through our activities and our group projects throughout the semester.